Howdy folks. So this just arrived in the mail today. This I ordered off eBay quite a while ago. I actually had to look up what it was called, and the listing just calls it an LCR-T4 meter. There apparently are a bunch of T3 meters out there. This is obviously just some design that's been copied by a bunch of manufacturers. And the T4 appears to have a different firmware version, a newer firmware version to the older versions. So that's why I ordered this. It wasn't terribly expensive. I think it was $20 Canadian, something like that. And this is sort of one of those general purpose sort of test everything kind of devices. So it's got a ZIF socket here, and you can test capacitance, ESR, inductance, resistance. You can determine gain of transistors, diodes, things like that. And it's sort of, you just plug it in any way, it'll tell you what the pinout is, all that kind of stuff. It's exactly the same as the Peak Electronic devices that I have. I'm not sure if this came first. I doubt it, but I'm not sure. Let me actually go get those, just so that you know what I'm talking about. So you may have seen these in my previous videos. I own these two devices from a company called Peak Electronic Design. They're a European company. I had to import these. It was not cheap, but it was definitely worth it. I like all the stuff from this company. They all have this kind of unusual form factor and interface, but the simplicity I like, and the components they're quite accurate, and they do their job well. I have this, which is an ESR meter, so it gives you capacitance and ESR. And this is a semiconductor analyzer, which has got 3 leads on it, and you can do USB curving and curve tracing and things like that, which I've done in another video. So these are both great devices, but unfortunately I don't have the full arsenal of their equipment. It's very expensive. They do sell a whole bunch of stuff. They sell units specifically for Zener diodes, inductors, this and that. But I mean, again, it's very expensive, and these were the first things I bought, and I haven't gone back and bought more just because of cost, pretty much. And one of the problems I run into a lot is I can't test inductance, and this does not go down very low in capacitance. I think I'd have to check, but I think it's 3 microfarads is the lowest capacitance this will measure, which makes it pretty much useless on any kind of ceramics or things like that. So I wanted something that could measure low capacitances and inductances pretty much. Everything else is pretty much covered by these two devices. So that's what I bought this for, because this thing does everything that those two units do and way more. And it was $20. So I thought I would give it a shot, see how it works, if it works at all. I can sort of test the calibration against my others, and I'll do that here for you today. There really is no need to do a teardown on this because it's bare PCB. It doesn't come with a battery, it's just a 9-volt battery clip. And the first thing I noticed when I got this out of the box, and I'm not sure if you can see this, is this screen is scratched to all hell. It's got all sorts of really deep gashes in it, and it looks like this screen was repurposed, like it was ripped out of some used piece of equipment and then installed on this, because I don't see how that could possibly have happened during shipping given the amount of bubble wrap this thing was wrapped in. So that's interesting to see how they're doing that. In terms of other build quality type things, the ZIF socket feels pretty limp compared to some of the nicer ZIF sockets that I've used for like microchip PIC programming. I have a unit with ZIF sockets. It's not bad. I mean, all the contacts work and everything with all different size leads. I mean, I haven't had a problem with it. It just doesn't feel very high quality. But then again, what should I expect for $20, right? We've got a very, very big clicky push button here. And that's your only button. It's basically the on test button, and it just when the unit's already on, you can just push it and it resets it and runs a new test. So the firmware is very simple. The ZIF socket you can see is labeled here 123111. So the bottom row, from what I can see, doesn't really appear to do anything. I can plug stuff in the bottom row, it doesn't work. Only the top row appears to actually do anything. So 1, 2, and 3, those are your 3 contacts, and they're also bridged out here onto these pads. So you could, I guess you could solder leads onto this, and I'm going to test it with some leads shortly, so you can see how the performance is if you don't have a component that can plug in here, but you want to test like something that's not necessarily in circuit, but something that doesn't fit in here. You could obviously make leads for this. It's fully backlit, so you can use it in the dark. On the back here, it's based around an Atmel AT Mega. Let's get the magnifying glass out. Oh boy. That's some mad glare there. Let me just... Oh, this flashlight. That is an Atmel AT Mega 328P. So that's what they're running everything with. I mean, there's really not much on this thing. Just that, some resistors. There's a 78 LO5 there for the 5-volt regulation from the 9-volt battery. Some transistors and an 8 megahertz crystal, and that's pretty much all that's on this. So they're obviously using the internal ADCs and stuff. So obviously your accuracy is going to be based off of that. We have a 2014 date code, some weird, I want to say that looks like a bird to me. There's a URL which I'm not going to go to. The way they've soldered the backlight on is a little ghetto. It just sort of wraps around the board, and that's not really reliable in my opinion. But the rest of the soldering is okay. So anyway, yeah. Also, that flex at the top is really not protected. So that is probably a likely point of failure. So anyway, if you turn it on, it just says M-Tester v2.07 testing, and it's got some sort of a copyright at the bottom, and just says no part basically, and you can press it again. Gives you the battery voltage, which is nice, I guess. So at least you know when to replace the battery. So let's give it some parts. So, first of all, I have this Panasonic or Matsushita 33 microfarad capacitor. This is a really high quality capacitor. So, actually, before I do that, let's get out the trusted meter, the thing that I actually believe, and see what this actually measures. So it measures 31.81 microfarads with an ESR of 0.34 ohms. Okay, so we'll say 32 microfarads, 0.34 ohms. And this thing, I'll just insert it wherever, I guess. And it takes different times to test depending on what component you use. So it measures 33.57 microfarads with an ESR of 0.35 ohms, and it's got this other parameter VLOS 0.6%. Not entirely sure what that is, but I mean the ESR is pretty much dead on, and the capacitance is out by about 1 microfarad, give or take. 1.5 microfarad to 2 microfarads. So, I mean, I guess you get what you pay for, but that's not terrible. You can't turn it off, you can't keep it on, unfortunately. It's only got one button, so you kind of got to quickly read everything on the display before it shuts itself off. So that's not bad. In terms of capacitance, let's look at these are 15 puff capacitors. Now, I have no way of actually measuring their real value because I don't own anything that can test this low, and I believe this is out of the spec of this device. It shouldn't be able to test this. Okay, and it can't, and that's fine. So what I'll do is I'll take 2 of these, both 15 puff, and I'll put them in parallel, which should give us 30 puff, which I believe is in the spec of this device. So we should get somewhere around 30 puff. 31 puff. Okay, that's pretty impressive. So that's good. So it can measure things quite low down, and that's good. That's what I really bought this for. Mostly things in the nanofarad range and stuff like that I can't test with the other one. So here we have a resistor, because it can do resistance. So this is a red, red, brown. Let's just pop that in there. I seem to use pins 1 and 3 most of the time because they're the right spacing for most components. 214.6 ohms, so nothing wrong with that. Definitely within tolerance. We can also test transistors. This is some sort of an NPN transistor. Not a freaking clue what the specs are, and I'm not going to bother to look it up. And it detects it as an NPN. It gives us the gain and the forward voltage. I mean, that's not bad. That's not bad. Let me test this transistor with the semiconductor analyzer. Try and remember those numbers. And I will hook this up here. So I mean the peak tester is better if you have a component in circuit or something that you got to connect leads to, whereas this T4 meter is better if you have components that are, you know, brand new with well-formed leads. But I guess whatever. So this one measures the gain a little bit lower, 219, and yeah, I mean it's not the same, but it's close enough. I didn't buy this for measuring semiconductors, but I mean it does a passable job if you were, you know, in a pinch, I guess. But I wouldn't use this as a main meter. The semiconductor analyzer can detect ICs as well, like voltage regulators. This is the LM317, one of my favorite ICs. Let's pop it in here. Don't think it's supposed to be able to figure this out, but we'll find out. Okay, now that's interesting. So I didn't figure out what it was, but you see this? This is some sort of like a firmware glitch. It's got a 4, and that looks like a diode symbol, sort of. So this is definitely a firmware bug. And if I flip this around, sometimes on the peak meter, if you actually flip the components around, you get different values, or sometimes it works one way but not the other way. But yeah, there's definitely a firmware bug, at least in that orientation. Yeah, we get the same funky artifacting, because if I take the component out and I just do a test without a component, it just gives you the question mark. So that's weird. So there are firmware bugs in this, which is not great. Anyway, so the last thing I wanted to test was in an inductor. And of course this inductor is far, far, far too big to plug in here. So what I did was I took a paperclip, because they are the universal connectors, and just chopped it in half. And I will basically make this a leaded device by just shoving that in the ZIF socket. Everyone who's into metrology and accurate measuring of stuff, look away now, because this is where it's going to get a little nasty. So now it's got leads on it, so now I can plug this in, and we'll see how it does inductors. Okay, inductor, 0.7 ohms, 0.05 millihenries. No way of verifying whether that's correct, but I mean, given the size of the inductor, I'd say that's probably right. So that's not bad. So let's go back to the tiny 15 puff capacitors. Now, obviously, this thing has no way of canceling lead capacitance like a proper LCR meter. So I just want to see, just for shits and giggles, I want to see how much. This measured 31 puff before. I'd love to see how much it measures now with leads, just out of curiosity, and whether that's repeatable or not. Because I mean, you could always just test the leads and then test the component with the leads and then just subtract them if you really had to, which is what I might do if it works out that way. So it's 40 puff. Okay, so I mean, it still works with the leads, and it's not terrible. 38 puff. 38 puff. Just want to see how reliable this is. 38 puff. Okay, so I mean, it's at least appears to be repeatable. So I could claim that the leads have 7 puff or so, and go from there. But of course, if you move them around, it changes things. But it's not terrible. So overall, I mean, I don't think this thing is terrible. For the price, I mean, I think between the two of these and shipping them and everything, I mean, I probably spent like $500 or something like that, at least. I don't even remember, to be honest. It was a long time ago. So, I mean, if you just need something quick, and you don't want to pay hundreds of dollars for an LCR meter, yeah, I mean, you just have to take everything with a grain of salt, pretty much, that comes out of this. And this weird salvaged LCD thing doesn't make me terribly happy, but I mean, at least it works. So yeah, I mean, you could very easily solder some leads onto this, maybe some clip leads, just like what I've got here, except instead of doing it the ghetto way, actually put them on here. And actually, you know, now that I think about it, that's probably not a great idea, because if you ever wanted to use this socket, they would, for especially capacitance, they'd get in the way. So yeah, maybe you don't want to solder something on there. Anyway, what you do with it's up to you. I mean, it's very easy to modify, because I mean, it's very simple and it's all accessible. But now I'm just rambling on. So yeah, that was my review of it, and it's good enough. Not perfect, but good enough, and definitely a ripoff. I'd love to see if anyone has another one of these. Maybe they bought it at a different time, or they have one from a different seller or whatever. If you have that weird glitch, or a different firmware version, does it have that glitch? Because I don't know if you can update this. I don't see any obvious... actually, now that I say that, that's probably a programming header right there, those 6 pins. So, I mean, if you had a programmer for the Atmel, you could probably update the firmware should someone put it somewhere. But that being said, I mean, I'm a PIC guy. I only have a PIC kit too, so I don't have a way of programming this at the moment. But yeah, if you've got a different version or something, by all means, let me know in the comments what other weird firmware quirks the thing has, because that's interesting. It's the only thing that I've tested that's given me a problem is the LM317, and I'm not entirely sure that it's even supposed to be able to test voltage regulators, so I'm not faulting it for that. But anyway, hopefully that was useful for somebody. Thanks for watching.